Assalamu alaikum dear students. Hope all of you are doing great. We will be continuing with the same component matrices of the topic matrices and determinants. Today's MCQs are based on types of matrices, right? Means types of matrices will act as an important tool and prerequisite for today's MCQs to solve. And let us have a quick look over types of matrices. You might have come across these types of matrices. Number one, that is row matrix. Row matrix, which is also called row vector or row vector. Similarly, we have column matrix. Column matrix, or it is also called column vector. It is also called column vector. We have rectangular matrix. Rectangular matrix. It has three subtypes. Number one, square matrix. Square matrix. Number two, horizontal matrix. Horizontal matrix. And number three is vertical matrix. Vertical matrix. Similarly, we have scalar matrix, we have identity matrix, we have diagonal matrix, we have null matrix, we have upper triangular matrix, upper triangular matrix. Similarly, we have lower triangular matrix. Okay, we have symmetric matrix and skew-symmetric matrix that have already been discussed in previous lectures, in previous video. So, besides these types of matrices, we have few more types like orthogonal matrix, orthogonal matrix. Number two, idempotent matrix. Idempotent matrix. We have involutory matrix. We have nilpotent matrix. Or today's MCQs are completely based on these four types of matrix, right? Let us have a look at this MCQ. It is written here, if A is an orthogonal matrix, then which of the following is true? यानी अगर A एक orthogonal matrix है, तब जाके इनमें से सही ऑप्शन क्या है? मगर हम पहले ये देखना चाहेंगे कि ऑर्थोगोनल मैट्रिक्स किस मैट्रिक्स को कहा जाता है. इफ वी टेक ए स्क्वायर मैट्रिक्स A is a square matrix. If we multiply it by its transpose, if we multiply it by its transpose and we get identity matrix, then this matrix is called an orthogonal matrix. यहां पर हमने क्या किया, यहां पर हमने A को इसके ट्रांसपोज से पोस्ट मल्टीप्लाई किया. अगर आप इस A को इसी A के ट्रांसपोज से प्री मल्टीप्लाई भी करोगे तब जाके भी आपको आइडेंटिटी मैट्रिक्स ही मिलनी चाहिए. तो हम कहते हैं A जो है ये ऑर्थोगोनल. देखिए, फ्रॉम रिकॉल मैंने आपको पढ़ाया है इनवर्स ऑफ ए मैट्रिक्स. मैंने आपको ये बताया कि इफ A इज ए स्क्वायर मैट्रिक्स, if there exists another square matrix B of the same order such that A multiplied by B is equal to B multiplied by A is equal to an identity matrix, then we say A is an invertible matrix and B is its inverse. Look here, आप जरा कंपेयर करिए इसको और इसको, आप कंपेयर करिए, देखो आपको क्या मिलता है. आपको मिलता है कि यहां अगर B A का इनवर्स है तो यहां पर A ट्रांसपोज जो है ये A का इनवर्स है. सो इट मीन्स दैट a square matrix whose inverse is its transpose is said to be an orthogonal matrix, right? So हम चलिए हम फिलहाल इस डेफिनेशन का इस्तेमाल करते हैं इस MCQ को सॉल्व करने के लिए. Look here. Now what is written here in the MCQ? It is written that A is an orthogonal matrix. So if A is an orthogonal matrix, it means that it is transpose. If we post multiply by its transpose, you will get an identity matrix. You will get an identity matrix. Fine. So now look here, look at this option. Is A transpose an orthogonal matrix? Is A transpose? Okay. Now, what is the first option? First option is A transpose an orthogonal matrix? So for that, what we have to do? We have to show that A transpose multiplied by A transpose whole transpose should be an identity matrix. अगर ये चीज आइडेंटिटी मैट्रिक्स के बराबर आया, इसका मतलब ये हुआ कि A ट्रांसपोज जो है ये ऑर्थोगोनल मैट्रिक्स है. तो जरा आप यहां पर प्रॉपर्टीज का इस्तेमाल करिए. आपको क्या मिलता है? इट इज A ट्रांसपोज हियर. नाउ A ट्रांसपोज होल ट्रांसपोज इज द मैट्रिक्स इटसेल्फ. नाउ A ट्रांसपोज A is equal to I, so it is an identity matrix. Look here. So from this it is clear that A transpose is an orthogonal matrix. So option 1 is correct. Let us have a look on option number 2. In option number 2 it is written here, is A transpose whole transpose an orthogonal matrix? Let us take it here. It is A transpose whole transpose. Recall property of transpose of a matrix. Transpose of transposed matrix is the matrix itself. So it means that it is A. But A is an orthogonal matrix. So it means that this is an orthogonal matrix. Right? So it means that option B is also correct. So now here, third option is both A and B. Option 1 is correct and option A is correct and option B is also correct. It means that option C is most appropriate. There is both A. Okay. So let us come to next. Look here. In this MCQ, it is written that A and B are orthogonal matrices. Then which of the following is? AB is orthogonal, BA is orthogonal, both A and B, and D is none of these. Let us take this condition of this MCQ into consideration. It says that A is orthogonal and B is also orthogonal. So we write here, since A is orthogonal, it means that A transpose is an identity matrix is equal to A transpose A. Similarly, B is an orthogonal matrix, so it means that BB transpose is an identity matrix is equal to B transpose into B. ठीक है, अब हमें क्या दिखाना है कि क्या AB ऑर्थोगोनल मैट्रिक्स है. AB हमें देखना है कि क्या ये ऑर्थोगोनल मैट्रिक्स है. उसके लिए हम क्या करेंगे, उसके लिए हम AB लेंगे. ठीक है, अगर हम इस मैट्रिक्स को अपने ट्रांसपोज से पोस्ट मल्टीप्लाई करेंगे या प्री मल्टीप्लाई करेंगे, दोनों केसेस में ये आइडेंटिटी मैट्रिक्स आनी चाहिए. अगर ये आइडेंटिटी मैट्रिक्स के बराबर आई तो हम ये कह सकते हैं कि AB जो है ये ऑर्थोगोनल मैट्रिक्स है. सो यहां पर क्या करेंगे, हम AB को अपनी जगह पे लिखते हैं और यहां पर हम रिवर्सल लॉ ऑफ ट्रांसपोजेस का इस्तेमाल करेंगे. और रिवर्सल लॉ ऑफ ट्रांसपोजेस सेज वी कैन राइट इट इन दिस वे, B ट्रांसपोज A ट्रांसपोज. हम इसको ऐसे लिख सकते हैं. नाउ लुक हियर, keep A as it is. What about BB transpose? Look here, BB transpose is an identity matrix. We write here I and A transpose as it is. Well, we know that if any matrix is post multiplied or pre multiplied by an identity matrix, we get the matrix back. So it means that this gives matrix A back, and in the right side we have A transpose. Now again we make use of this here. A transpose is an identity matrix, so this is an identity. Look here, AB into AB whole transpose is an identity matrix, means that AB is orthogonal matrix. So this option is correct. Similarly, if you solve this one, BA is an orthogonal matrix, right? If you solve this option like this, you will get BA is also orthogonal, and therefore option C is the most appropriate. Okay, so let us come to next one. Let's have a look here. It seems to be very important one. It is written here, if A and B are real non-zero 3x3 matrices, means both the matrices are of the same order 3x3. Moreover, the elements inside these matrices are real numbers which are not zero, and satisfy the equation AB whole transpose plus B transpose A equal to 0. And it is also written here, if B is orthogonal, then A is symmetric, schizo-symmetric, both none. Okay, let us make use of this condition and this, which is given. Let us take this condition, first one. Let us take second one first, this one. Okay, B is an orthogonal matrix. What does this mean? It means that BB transpose is an identity matrix. So it means that BB transpose is an identity matrix. It is equal to I, because B is an orthogonal matrix. Now let us take second condition into consideration. Second condition is AB whole transpose plus B transpose A is equal to null matrix. Use reversal law for transposes. You will get here, it is B transpose A transpose plus it is B transpose here, and A is equal to null matrix. Let us pre-multiply both sides by B. So what do we get here? You will get B multiplied by B transpose A transpose, B transpose A transpose, okay, plus it is B transpose A is equal to B multiplied by null matrix. So what do we get? Just multiply here and make use of distributive law. Matrix multiplication distributes over addition. So you will get here B transpose A transpose plus B transpose A, and you know that any matrix multiplied by null matrix is a null matrix. So make use of this here. BB transpose is equal to I. Let us use I instead of this here. It is A transpose plus BB transpose. Again it is I, right? And then it is A is equal to null matrix. We know that if any matrix is multiplied by identity matrix, we get the matrix back. So you get here A transpose plus you will get here A, which is equal to what? It is equal to null matrix. Now this equation is possible only if this and this cancels out. Or in other words, you can say that this equation is possible only if this matrix is the additive identity of this matrix. Additive inverse of this matrix, sorry. So it means that this matrix has to be negative of A. Then this and this gets cancelled out and we get null matrix. So it means that what we do here, we can say this equation is possible only if your A transpose is equal to negative A here. ये तभी जाके पॉसिबल है अगर ये नेगेटिव ए होगा, बिकॉज नेगेटिव ए एंड पॉजिटिव ए गोज एंड वी गेट आइडेंटिटी नल, दिस नल मैट्रिक्स. तो यहां पर इस कंडीशन का होना बहुत जरूरी है. तो इसका मतलब जब किसी भी मैट्रिक्स का ट्रांसपोज नेगेटिव ऑफ दैट मैट्रिक्स होता है, हम जानते हैं तब जाके वो सिक्यू सिमेट्रिक मैट्रिक्स होती है. इसका मतलब ये हुआ कि ए का सिक्यू सिमेट्रिक होना लाजमी है, राइट? ए का सिक्यू सिमेट्रिक होना लाजमी. तो ये देखिए, ये आपके सामने, ये मुझे लगता है ये बहुत इंपॉर्टेंट है, इसको आप ध्यान से देखिए. तो लेट अस कम टू नेक्स्ट वन. And next one is now it is here. This MCQ is based on idempotent matrix. So what is an idempotent matrix? इस किस्म का MCQ हमने इसे पहले भी किया है, पिछले वीडियो में किया है. Let us have a look. When a square matrix is said to be an idempotent matrix, a square matrix A is said to be an idempotent matrix if its square comes out to be same matrix. अगर एक स्क्वायर मैट्रिक्स का स्क्वायर करेंगे हम और वो वही मैट्रिक्स वापस आएगी, तब जाके हम उस स्क्वायर मैट्रिक्स को कहते हैं ये आइडेम्पोटेंट मैट्रिक्स है. ओके, सो अब देखिए जरा इस एमसीक्यू को आप ध्यान से देखिए. यहां पर लिखा है कि इफ A एंड B आर आइडेम्पोटेंट मैट्रिसेस, देन AB इज एन आइडेम्पोटेंट मैट्रिक्स इफ A is equal to B, AB is equal to BA, A is not equal to B, none of these. Now look, let us make use of this condition. Okay, it is written here A is an idempotent matrix. It means that its square is A. B is an idempotent matrix means B square is equal to B. अब हमें ये मैट्रिक्स देखनी है कब आइडेम्पोटेंट मैट्रिक्स हो, मैट्रिक्स. ओके, और इनमें से कौन सी कंडीशन के तहत ये आइडेम्पोटेंट मैट्रिक्स बनेगी. अब देखिए हमें क्या करना है. अगर हमें ए बी का हम स्क्वायर लेंगे, अगर ये ए बी के ही बराबर आया, तब जाके ये ए बी जो है ये आइडेम्पोटेंट मैट्रिक्स. लेट अस सॉल्व इट फर्स्ट. क्या ये इसके बराबर आता है कि नहीं? सो रिकॉल पॉजिटिव इंटीग्रल पावर्स ऑफ ए स्क्वायर मैट्रिक्स. आपने उसमें ये देखा है, दिस इज अ स्क्वायर मैट्रिक्स, राइट? इज अ स्क्वायर मैट्रिक्स, स्क्वायर मैट्रिक्स. इनफैक्ट दे आर ऑफ द सेम ऑर्डर. नाउ AB whole square means that you have to multiply AB 2 times. If possible, suppose this matrix BA is equal to AB. BA matrix is equal to AB. If possible, suppose. We don't know whether it is or not, because matrix multiplication is not commutative in general, so we can't say that BA is equal to AB. For the sake of convenience, we take BA to be equal to AB. Let us see what will happen here. So you will get here, it is A, instead of BA we write here AB. It is here AB, then it is here B. So which is equal to A into A is A square, it is here B square. Now what is A square? A square is A. And what is B square? It is B. So means that this AB whole square is equal to AB is possible only if BA is equal to AB. So it means that if A and B commute, so option B is correct option. Okay, let us come to next. Next MCQ is, if A and B are idempotent matrices, then A plus B is idempotent if AB equal to BA, AB equal to 0, null matrix. In fact, C part is AB is not equal to BA and none of these. Let us take this. It is written here, let us make use of this condition that A and B are idempotent matrices. So if A is idempotent matrix, it means that its square is the matrix itself, and B is idempotent matrix means its square is the matrix B itself. Okay. Now what we have to check? We have to see. We have to look whether this A plus B is idempotent or not. We have to search for it. Under which condition it is true? AB is an idempotent. So what we do, let us take an A plus B, it is square. Let's take the square of A plus B. If it comes out to be the same matrix A plus B, then A plus B is idempotent matrix. Okay, let us see under what condition it comes out to be A plus B. So A plus B whole square means we can write it in this way. It is A plus B into A. So this is here. A into A is A square plus A into B is AB plus B into A is BA and plus B into B is B square. What about A square? A square is A. A square A के बराबर है plus it is here AB plus it is here BA plus B square is equal to B. It is equal. Okay. Now, we want this A plus B whole square to be equal to A plus B. So, which is possible only if this one is null matrix and also this one is null matrix plus B, right? So, which is equal to A plus B. So, it means that this A plus B is an idempotent matrix if and only if both A into B and B into A are null matrices. So this one is the correct option. A is equal to AB is null matrix. Fine. So let's come to next one. Let's come to next one. Here it is written that if A is an idempotent matrix and A plus B is an identity matrix, then B is idempotent if AB equal to BA, AB equal to BA equal to null matrix, B is of order 2 cross 2 only, and D part is none of these. Okay. So let us make use of this condition, and so A is an idempotent matrix. What does this mean? Again, A square is equal to A. Okay. Now let us take this condition into consideration where it is written A plus B is an identity matrix. Well, let me take this A to right hand side. You will get B as identity matrix minus A, which let us pre-multiply this equation by B or post multiply. Let us pre-multiply it by B. You will get B into B is equal to B into identity matrix minus A. Well, B into B means B square, which is equal to, it is B into identity matrix minus B into A. Okay, this implies it is B square is equal to B into identity matrix is the matrix itself minus it is BA. राइट जरा यहां समझिए आप इस बात को. यहां पर हमें यह दिखाना है कि B इज आइडेम्पोटेंट इफ AB इक्वल टू BA, AB इक्वल टू BA इक्वल टू नल मैट्रिक्स. देखिए अगर मैं यहां पर इसको नल मैट्रिक्स लेता हूं, मैं ये नल मैट्रिक्स मानता हूं, क्या मिलेगा? B स्क्वायर विल बी इक्वल टू B माइनस नल मैट्रिक्स, मीन्स B स्क्वायर विल बी इक्वल टू B. So it means that B is idempotent only if BA is a null matrix, right? So BA is a null matrix is given in option number B. So option number B is the correct option. Let us come to next one. And the next one is, let me give you this as home assignment. You will try it yourself. It is very simple. If this is the matrix, is an idempotent matrix, and f of x is equal to x minus x square and BC equal to 1 by 4, then the value of this is, right? It's very simple. Let me, as an home assignment, you will try it yourself. Okay? So it is enough for today, today's lecture. Let's meet